Okay, here we go. Lesson number 2, 6.1b lesson, side relationships and triangles. So before I get started here, I wanted to tell you that I have a webcam on my laptop, and I wanted to show you a picture of me sitting on the couch with my dog, but I've got a dark brown blanket on me. My dog is black, and when I look at this, you can't see the dog. All you see are my double chins and my laptop reflected in my glasses. It was the most unflattering picture of all, so you're just going to have to listen to my magnificent voice. This was your homework last night. Stop laughing. This was your homework last night, and I asked you to go on GeoGebra and practice building triangles for the 3 given side lengths. And it's kind of interesting, isn't it? Hopefully you saw that it was impossible to build a triangle, and I'll scroll down here. It was impossible to build a triangle when the third side, the longest side, was too short. So for letter B, when we tried to build a 1, 2, 3 triangle, the 1 plus 2 sides weren't long enough to connect to a side length of 3. That happened on letter B. It also happened on letter D, where the 1 plus the 3 wasn't long enough to connect to the 4, and the 2, 5, and 7. And those of you that are observant will have noticed that we can only create a triangle when the sum of the 2 sides is greater than the length of the third or longest side. So on letter A, 2 plus 2 is 4, 4 is greater than 3, and therefore we could build a triangle. On letter B, 1 plus 2 is 3, 3 is equal to 3, and a triangle was not possible to build. So to save you a little bit of time, I've gone ahead and finished number 4 and number 6 for you. Number 5 is not appropriate. It's from last year's lesson. So basically what I said, and here's my conjecture, that the short side plus the medium side, their sum must be greater than the longest side, because otherwise the triangle can't have 3 sides, the 2 sides can't connect. And then going down to number 6, is it possible to have a triangle such that the sum of the measures of the shortest and medium sides is equal to the measure of the longest side? And that's what we saw in the exercise that you did at home for letter B and D and F. And you can see you can't close those 2 lines. If you try to close them, you end up collapsing those 2 sides onto the longest side, and you have a collinear line. And then finally, number 7, the logical reasoning. I'm going to have you try this one on your own. The hardest part of this, I think, is parsing what they're trying to get at. So I'll read it to you. If the sum of the measures of the shortest and medium sides of the triangle is greater than the measure of the longest side of the triangle, we can conclude that the sum of the measures of any other pair of sides of the triangle will be greater than the measure of the remaining side. Explain why this conclusion is possible. So what I'd like to suggest is you pick a triangle from the previous page that was a yes, that actually worked. Sketch that triangle and prove what it is they're trying to ask you to do here. So with your group, I'm going to give you 3 or 4 minutes. We'll set the timer. Let's pause the video, and I'll see you back when you're finished, and let's see if you had the same conclusion I did. Please pause the video now. All right, so hopefully you had a good discussion in your group. Here is exactly what we're talking about in this problem. I drew a 4, 5, 7 triangle, and it says that the small plus the medium must be greater than the long side. Or short plus medium is greater than the long. So I showed 4 plus 5 is greater than 7. And that is true because 9 is greater than 7. Now let's juggle those sides around. What about the short side plus the long side? Is that greater than the medium side? Which is exactly what they're asking us to conclude. And the answer is yes. 11 is greater than 5. And then if we juggle the third time and we put the medium and long side together, we get 12 is greater than 4. So this conclusion is possible because if the first relationship holds, then obviously the other two will hold as well. So pretty straightforward, nothing fancy there. You probably never thought about it before, neither had I, but it's absolutely true. All right, let's turn the page, see what's coming next. In the box below, write 3 inequalities that are always true for a triangle with side lengths A, B, and C. These inequalities should be based on your conclusions from question 7. As a reminder, an inequality is when the two values are not equal. For example, 5 is greater than 7 and 8 is less than 11 are inequalities. All right, would you please complete this box and finish numbers 8 and 9? And talk about this with your group, especially number 8, which 2 inequalities above are understood within the third inequality. And then start the video again and we'll talk. Okay, please pause the video now. Okay, well, I hope that you got the triangle inequality theorem, which are these 3 statements, just a restatement of what was done before. And the key to this entire idea of the triangle inequality theorem is finding the longest side. So once you've identified the longest side, then you can just get by with what you see in number 9, the master theorem, which is A plus B is greater than C, where C is the longest side. So that's what I'd like you to keep in mind as you're doing numbers 10 through 17. Numbers 10 through 17, find the longest side. So I'll demonstrate number 10 for you. Longest side. Which one of these is the longest side? You don't have a ruler, you don't have a protractor. However, angle F is the only obtuse angle. And because the size of the angle determines the length of the side, this side, side D at E, using your notation, that's side DE, is the longest side. So if that is the longest side, in any order, it's totally arbitrary, you're going to say that side DF, again proper notation, plus side FE must be greater than side DE. All right, that's what you're going to do for number 10. Number 11, and that's all you're going to do. And then if you'll turn the page, you can see it's a similar sort of activity here for numbers 12 through 17. Your first step is finding the longest side. So for number 12, determine if it's possible to form a triangle with the given side lengths. Justify your answer using the triangle inequality theorem, which means first step, find the longest side. Second step, do the one triangle inequality that you have to show, which is the short side plus the medium side is greater than the largest side. Don't leave it like that. Tell me what the sum of 3 and 4 is. 3 plus 7 is 4. 3 plus 4 is 7. 7 is greater than 8. No, it's not. So is it possible to form a triangle with these side lengths? No, it is not. This is the triangle. Sorry, I'm trying to draw here. Triangle inequality. Well, never mind. I'm not going to do that. I can't use that. I can't use that abbreviation for the triangle inequality theorem. I'm just going to have to say it out loud and stop laughing. Okay, so your task is to go back to number 11 and then finish numbers 11 through 17, then stop. Number 11 through 17, then stop. This should be fast. I would say 8 to 10 minutes. Please pause the video now. Stop laughing. Okay, so hopefully that was pretty straightforward for you. Taking a look at number 11, the triangle inequality statement is side AB plus side BC is greater than side AC. Using the numbers to prove it, you get 5 is greater than 4, which means that yes, you can form this triangle. Turning the page, taking a look at numbers 13 through 17. Again, the question is it possible to form a triangle with these given side lengths? You're using the triangle inequality theorem to justify it. Please take a second and make sure that your answers are correct. Notice I have taken this extra step of always circling the longest side. When I don't do that, I make careless errors. So do yourself a favor and take that extra step. All right, then finally, and this isn't finally, this is the next to the last page. Determine the least possible measure of the third side of a triangle with the given side lengths if the missing measure is a whole number. Show your reasoning using the triangle inequality theorem. All right, so what we're looking for here is the least possible measure of the third side of the triangle. So for number 18, if I have one side that's 12 meters, one side that's 15 meters, am I looking for the longest possible side or the shortest possible side based on these directions? That's right, we're looking for the shortest possible side. All right, so if I'm looking for the shortest possible side, I'm going to call that x. So let x equal the shortest possible side. And notice they want this as a whole number. So x equaling the shortest side is what it's going to be for every single problem, 18 through 21. All right, here's what my work is going to look like. Of these two numbers, 15 is the longest possible side. So I'm going to say x, the shortest side, plus 12, my medium side, must be greater than 15. And obviously, when I subtract 12 from each side, and you don't have to show this work going forward, but I'm going to show it for the first one, x must be greater than 3. So the whole number that is greater than 3 would be 4. Therefore, the least measure, or the shortest possible side, is 4, and put your units in here, meters. Okay, that's the first problem. That's exactly what you're going to do. So I'd like you to complete numbers 19 through 21, and then using similar logic, number 22. If two side lengths of a triangle are 5 centimeters and 7 centimeters, what is the largest possible whole number length of the third side? And you're going to justify your answer using the triangle inequality theorem, which I am not going to abbreviate for you. Okay, so your task is to finish this page, numbers 19 through 22, in your group. When you're finished, the sub will start the video again, and you can see how you did. Okay, please pause the video now. Okay, I think that was a pretty straightforward assignment through number 21. Be sure that you have units on your final answers. So double check those. Let's take a look at number 22 using the exact same logic. Now x is your longest side. So 12 is greater than x, which means that 11 centimeters is the longest whole number length. Be careful here. If I asked you what the longest decimal answer length would be, the longest decimal answer length, and I'm talking about decimal to the nearest tenth, what would your answer be to the nearest tenth? If you were thinking 11.9 centimeters, you're exactly right. So be careful to read the question. Make sure you answer the question that is asked. Okay, and then finally, if you turn the page, the very last thing you're going to do, and I'm not going to show you the answer to this one because I'm not going to draw this. It's hard to do on a tablet. Number 23. Carefully duplicate the triangle below using a ruler and a protractor. Label the side lengths rounding to the nearest tenth of a centimeter and angle measures rounding to the nearest whole number of degrees for your new triangle. B, then write an inequality that shows the triangle inequality theorem. And C, classify the triangle based on its sides and angles. Here's my tip for you. We've never done this. So for part A, you're going to begin with side BC, then use a protractor to draw angle B and angle C. Extend each line, and I'm talking about this line and this line, beyond vertex A, and don't bother to erase. Those lines need to cross, and you don't know exactly where they're going to cross, so extend them very far. All right, I am out of time. It's about to end. Finish this last thing, and then you're done. If there's time left, you can start your homework. Bye!